Hey guys, welcome back. Thanks for putting up with all of my lecturing about independent. So now we're just going to jump right into some examples. Now, just to remind you, two events are independent if the probability of their intersection is equal to the product of each probability. So if you missed this lesson, you can go back and watch it on my channel. So in this problem, I say the probability of A is 0.3 and the probability of B is 0.7. The probability of A and B is 0.21. Now, if these two events are independent, then these two probabilities will be equal. So 0.3 times 0.7 actually is 0.21. And because 0.21 equals 0.21, they're independent. So you should write, since the probability of A and B is equal to the probability of A times the probability of B, A and B are independent events. So that's how we can justify our answer. So once again, in order to determine if two events are independent, you're going to take the product of the two, multiply them, that's what product is, and then see if it's equal to their intersection. So let's try another example. The probability of getting a federal grant is 1/2. So we'll just denote it like that. The probability of getting a state grant is 1/3. The probability of getting both meaning and, federal and state, is 1/6. Determine if the events getting a federal grant and getting a state grant are independent. Well, in order to determine if two events are independent, you're just going to see if the intersection of the two events is equal to the product of the two events. So this guy here is 1/6, this guy here is 1/2, this guy here is 1/3. Remember, in order to multiply fractions, we multiply the numerator times the numerator, so 1 times 1, and 2 times 3 is 6, so that's 1/6. So in fact, federal grant and state grant are independent. In other words, if you got one of them, then that's not going to affect the way if you're going to get the other one. So you should state why they are. So you should say, since probability of F and S is equal to the probability of F times the probability of S, the two events are independent. You should write that down to receive full credit. Let's look at another example. The probability of being a math major is 0.2. The probability of being a science major is 0.25. If the probability of majoring in both math and science, since we can double major in college, is 0.28. Now I want to stop there for a second. I should really highlight a key word. This word here, both, refers to this symbol and. So if the probability of majoring in both math and science is 0.28, determine if the two events being a math major and being a science major are independent. In order for two events to be independent, their intersection has to equal to the product of the two. So this is 0.28, and this is 0.20, and this is 0.25. Now you should probably put a question mark right above that equal to first make sure that it is, or we don't know if it's equal or it's not equal, so we shouldn't really put that equal sign without that little question mark here. And we know that these two values would not be equal because 0.2 times 0.25 is going to be 0.05. And this guy here is 0.28. So since the probability of and S does not equal the probability of M times the probability of S, then the two events are not. So if they're not equal, then they are not independent. In other words, typically if you're going to be a math major and a science major, being a science major sort of has an effect on being a math major and so on. They're not independent from one another. They depend. Usually math and science people stick together. So there's probably some dependence, and so they are not independent. Now, back to our contingency table. I had male, female, Democrat, Republican. And I gave you the total. There are 20 males, 20 females. So there's 40 people total. Do you guys remember that from the videos? 40 is your total. 22 of the 40 are Democrats and 18 of them are Republican. Are the two events, being a female and being a Republican, are those two events independent? Well, in order to determine if two events are independent, you're going to see if their intersection is equal to the product of the two. So if you remember from my past videos, in order to find the intersection, you're going to go to the event female. I'm sorry, I should have put Republican there. I don't know why I just did that. I think I was still thinking about the science. So being a female and being a Republican. So you're going to go to female, and then you're going to go to Republican. And you're going to see where they intersect. Now, when it comes to a table, you're going to have to go up and down, left and right, and see where they cross. So they cross at 4. So it's 4 out of the total. Remember, it's always out of the total. Probability of female is going to be 20 out of 40. So that's this guy here. Probability of Republican is going to be 18 out of 40. And now you'll probably need a calculator to determine if the two are in fact equal. You shouldn't just say no without checking. So we know that 4 divided by 40 is just 0.10, but again, use your calculator. And we know that 20 out of 40 is 0.5, it's a half. And if we times that by 18 out of 40, which I'm doing right now, I should have done it earlier, we're going to get 0.225. So they are not equal. Therefore, they are not independent. So you're going to write, since the probability of F and R don't equal the probability F times the probability of R, the two events are not independent. You should not say they're not independent until you actually check these numbers. Sometimes they do equal, okay? And it might not look like it equals, but they do. Okay, so does not. Last problem. Is being a male and being a Democrat independent? Let's see. Male and Democrat. Does that equal to the probability of male times the probability of Democrat? Well, let's find their intersection. Go to male, go to Democrat. They meet at 6. 6 out of the total. How many males are there? 20 out of 40. How many Democrats are there? 22 out of 40. I don't believe these two numbers are going to be equal, but I'm just going to check anyway. This is going to be 0.15. And once again, I should put probably a question mark on top of it because you're still not sure. 22. And this is 0.275, and they're not equal. So since they're not equal, they are not independent. For those who are struggling with how to get 0.275, you can use your parentheses in your calculator, or you can say this times this divided by this times this. I hope you enjoyed. Come back for the next video.